to Data Do Library. Today we're going to talk about solving the exact differential equations. So an exact equation may look like something like this. 2xy dx plus x squared minus 1 dy is equal to 0. The first thing we have to do is test if this equation is indeed exact. So to do that, we're going to call this part of this equation some m in terms of x and y, and this part of the equation some n, function n in terms of x and y as well, even though this function in particular is only in terms of x, but it can be in terms of x and y. So in order to test if this is an exact equation, we have to find out if the partial derivative with respect to y of m is equal to partial derivative of n with respect to x. If they are equal, then you have an exact equation and you can go on to solving it. So first, the partial derivative of m with respect to y. Remember, when we're finding derivative with respect to y, a partial derivative with respect to y, we're going to treat x as a constant. Therefore, 2x will be my derivative because derivative of y is 1, and then we have the constant of 2x. Derivative of n with respect to x is also 2x minus derivative of 1, which is obviously 0. Since those two are equal, we can go ahead and move on and actually find the solution to this equation. Now that we tested and saw that this equation was exact, this means that there exists some function f of x and y such that partial derivative with respect to x is going to equal to the function m, and partial derivative with respect to y of this function is going to equal to capital N. So the first thing we want to do is pick one of these two. It doesn't matter which one you pick. For this example, I'm going to pick partial derivative with respect to x is equal to m. So what I'm saying is that the function, the partial derivative of this function with respect to x is equal to my function m, which is 2xy. So to find what that function actually is, I'm going to integrate on both sides. I'm going to find the integral of f with respect to x dx equals integral of 2xy dx, again with respect to x. Now this part is very important and a lot of times easily missed. We have to add another function here. We're going to call it f of y because we have this partial derivative with respect to x, but there could have been some function of y or a constant that produced a 0 for us, which is why we're going to have this function f of y added to this integral. So now I'm going to integrate. If I integrate the left side, I'm just going to have some function in terms of x and y as a result. And on the right side, integral of 2xy with respect to x. Remember, that means y we're going to treat as constant. So if you wanted to, you could rewrite this as y integral, or even 2y integral of x dx plus f of y. So again, on the left side, we have function of x and y is equal to 2y integral of x dx is x squared over 2 plus some function f of y. Now 2's cancel, and I am left with f x comma y is equal to x squared y plus f of y. So at this point, we're almost there. All we need to find out is what is this f of y? So we already did this part. We found the partial derivative of f with respect to x. Now let's work with the other piece of information that we have here, which is the partial derivative of f with respect to y, and that is equal to n. So the first thing I want to do is find the partial derivative with respect to y of my function. And since I'm finding the derivative with respect to y, x is now going to be my constant, and derivative of y is just 1. And derivative of f of y with respect to y is just going to give me f prime of y. Looking back here at the top, remember that partial derivative with respect to y is equal to n. So this whole thing is equal to n. And then n is nothing more than this function here on top. So now I can say that this x squared plus f prime of y is equal to my function n, which originally was x squared minus 1. Now notice some things will cancel here. X squared and x squared cancels, and all I have left is f prime of y is equal to negative 1. So I don't want f prime, I want f of y. So to find f of y, I just need to integrate again with respect to y. So on the left side here, I just have simply f of y, and on the right side, I have an integral of negative 1 with respect to y, would just be negative y plus c. So finally, I can go ahead and take that f of y that we just found and plug it into my equation, and I have x squared y minus y plus c. So the solution to this differential equation would just be x squared y minus y plus c equals 0. You can also move the c over to the other side. You can find the explicit or the implicit solution. So if I move the c over to the other side, since c is an arbitrary constant, it doesn't have to be negative. Minus y equals c. That will be my implicit solution. If I wanted to go even a little further and find the explicit solution, I would just factor out the y of x squared minus 1 equals c. Divide both sides by x squared minus 1, so c over x squared minus 1 would be my explicit solution to this problem. Before we go over our next example here, I encourage you to pause this video now and try to solve this on your own. I hope you pause this video and try to come up with an answer on your own. So the first thing you have to do is just to test to make sure that this is indeed an exact equation. So to do that, we have to find if partial derivative with respect to y of m is equal to partial derivative of n with respect to x, and we're going to call this function my m, and this function here my n. So when I take the partial derivative of m with respect to y, keep in mind to keep x constant. So the partial derivative of m with respect to y will be y times cosine x. Remember, x is constant, so that's going to come down, and derivative of y is just 1, plus 2x is constant again, and derivative of e to the y is simply just e to the y. Now we're going to find the partial derivative of n with respect to x. So just keep in mind that we're going to keep y, we're going to pretend that it's a constant and treat it like a constant. So the derivative of sine x with respect to x is just cosine x plus, again, e to the y is going to be treated like a constant, so I'm going to put that here. And then derivative of x squared is just 2x. And then derivative of 1, derivative of any constant, is obviously 0. So now you can see that indeed this checks out. Those two are equal. Therefore, we can go ahead and move on to solving it. As I mentioned in the previous example, now that we know that this equation is exact, we know that there exists some function f of x and y such that the partial derivative of x is equal to m, and the partial derivative with respect to y is equal to n. So again, it doesn't matter which one you start with. If you want to start with m, you want to start with n, makes no difference. For this example, I'm going to start with m again. So the partial derivative with respect to x is going to equal to y cosine x plus 2x e to the y. So I'm going to find an integral with respect to x of m. And as I mentioned before, one thing that many people forget is to add that function f of y, because we started off with the partial derivative in terms of x, which means there could have been some function y that turned into a 0. So we can't forget about that in order to solve this problem. Again, since we are taking this integral with respect to x, we have f of x comma y here. And on the right side here, we have an integral of y cosine x. So we're going to treat y as a constant again. And an integral of cosine is nothing more than sine x. Then we have plus e to the y, and integral of 2x is just x squared, plus my function of y. And this is the function we're going to maybe put like a little star next to, because this is the function we're going to come back to once we find what f of y is equal to. In order to find that, I'm going to need my second condition here, which is the partial derivative of this function with respect to y is equal to n. So that's what we need to do to this function. We need to find the partial derivative with respect to y. And when we're finding partial derivative with respect to y, keep in mind that x, again, is constant. So we have sine x, and then derivative of y is 1, plus x squared, derivative of e to the y is e to the y, plus derivative of f of y with respect to y, in this case, will be f prime of y. And again, going back to here, we know that f of y is equal to the same thing as n. And n was this function right here. So we can say that this is equal to sine x plus x squared e to the y minus 1. Now let's see what we can cancel. Sine x goes away, x squared e to the y goes away, and all we're left with is f prime of y is equal to negative 1 again. Now again, we don't want f prime of y, we want f of y, which means we need to find an integral with respect to y, just like in the previous example, which gives us f of y is equal to negative y plus c. So remember that star I asked you to put in here? Now we have to go back and plug that in. So what we have is y sine x plus x squared e to the y plus f of y, which we know is negative y plus c. So it's minus y plus c. That's equal to 0. So I once again encourage you to pause this video and try this equation on your own. If you are going to do that and want to follow along, I am going to start with my function n, which is the partial derivative of with respect to y. So I'm going to start with this part first instead of m, which is what I started with in the other example. So if you are going to follow along, just make sure you do that side first. Hopefully you had enough time at this point. You pause the video. And the first thing we want to do is make sure that m partial derivative of m with respect to y is equal to partial derivative of n with respect to x. So the partial derivative of m with respect to y, remember x is constant, we have e to the 2y times the derivative of 2y, which is just 2, minus, we're going to need a little bit of a product rule here. We have first, which is y, times the derivative of cosine xy. So times sine xy times the derivative of xy, which would just be x, because we're treating x as a constant, plus the second, which is cosine xy, times the derivative of y, which would just be 1. So to simplify this, we have to remember to distribute this negative through. So we have 2e to the 2y minus xy sine of xy minus cosine of xy. Now we're going to do the same thing to n. Now we're going to find the partial derivative of n with respect to x. So keep in mind y is now constant, so e to the 2y is going to come along, and derivative of 2x is just 2, minus, and we have product rule again, we have first, which is x, times the derivative of cosine xy. So x times the derivative of cosine xy with respect to x, which is be sine xy times y, which I'll just put it here, plus second times the derivative of the first, so it's cosine xy, derivative of x with respect to x is just 1, and then we have the derivative of 2y, which again is just a constant, which means it's going to be 0. And we're going to simplify that again, giving us 2e to the 2y minus xy sine of xy minus cosine of xy. Now we compare my n and my y, my partial derivatives of n and y, and see if they're the same. And indeed, they are the same. Therefore, we can go ahead and solve this. Now that we proved that we can go ahead and solve this, we know that the partial with respect to x is going to be equal to m, and the partial with respect to y equals n. And as I said in the beginning of this example, I'm going to start with the n part first, just to show you that it does indeed work. So I'm going to find the partial derivative, or my partial derivative with respect to y is n, which is 2x e to the 2y minus x cosine xy plus 2y. So as we did before, we need to find an integral with respect to y of all of this. And since this is a partial, we can't forget but to add that function. This time is going to be in terms of x. So I'm going to add that here at the end. In a more complicated example like this, sometimes it's very helpful to kind of rewrite this with some constants pulled with the constant term, or in this case, the x term, pulled outside of the integral and working on each one of these parts separately, as I will do. So here we have f of x comma y, and we have integral of 2x e to the 2y. Now we're integrating with respect to y, which means everything that's x is going to be a constant. I'm going to pull that out. So 2x, all I have left is e to the 2y dy. And minus, again, I'm going to pull out the x, and have integral of cosine xy dy. Plus integral of 2y dy, and I'm going to have some function of x. Now I'm going to go ahead and just integrate these. I have f of x comma y, is equal to 2x times the integral of e to the 2y, which is just e to the 2y, divided by derivative of 2y, which is 2, minus x, integral of cosine xy, which is sine xy, and again, since we're treating x as a constant here, let me divide it by x, plus, I'm going to take that 2 out, and we have 2y squared over 2, which is integral of y squared, and then plus some function of x. Now I'm just going to quickly simplify here. So f of x comma y is equal to, these 2's cancel. We have x e to the 2y. These x's cancel, which is minus sine xy. These 2's cancel, plus y squared, plus some function of x. And this is, again, when you put a little star next to this, because you know you have to come back to it to fill in what that f of x is actually going to be. So in this example, we used this already. So now we're going to use this part. We say the partial derivative of f with respect to x is equal to m. So let's find the partial derivative of this function with respect to x. Again, e to the 2y is going to be a constant, and derivative of x is just 1, minus derivative of sine is cosine xy times the derivative of xy, which in our case would just be y. Then we have derivative of y squared, which, since we're doing this in terms of x, y squared would just be is a constant, therefore it would be 0, plus f prime of x. Now we know that this function is equal to m. So I'm going to set this equal to m, which is here in our original equation, e to the 2y minus y cosine xy. And let's see what can cancel. We have e to the 2y, e to the 2y, negative y cosine xy, the same thing on the other side, which means that f prime of x is equal to 0. And since we don't want f prime, we want f of x, we're going to find an integral with respect to x. And integral of 0 is nothing more than a constant. Therefore, I can finally rewrite this as my final solution, x e to the 2y minus sine xy plus y squared plus c equals 0. And that is my final solution. Thank you again for joining me. Please subscribe, like the video, come back for more. Take care.